So do you remember web components? Well, Polymer came out and all that, and they didn't really serve a purpose at the time. Well, look at them again, because I think there's a change in the tides now, and I'm excited about web components. I never thought I would say that. I never thought this day would come, but web components are finally cool, I think. There's a couple of reasons for that. One is that, web is still king, has been king for a while, obviously, but the adoption of, my God, the adoption of web component compatibility in React 19, which is coming soon, just changes everything. Because the great promise of web components that kept us all waiting for the next season was that you could build a component library or write these components that you could use in Angular applications, React applications, which have a particular purpose, a particular value in design systems. For those who don't know, it's a glorified component library, and the glorification is in the form of like a design specification, right? So it's a more abstract layout of a brand guideline for UX that is then implemented, optimized for that company's functional needs, and then it's supposed to be shared across application teams. And it happens often with clients we work with that are larger enterprise, have many teams, that they'll have different platforms or some more legacy applications in AngularJS, some newer in React or Angular, and they need, like, sharing these is actually a big deal. You can save a lot of time for people, you can reach uniform look and feel, of course, tons of great things. The problem is, it didn't work for a long time, especially with React. There are some specific problems, technical problems that have made it, that has made it kind of unfeasible. It's just too much work to port them in, and there hasn't been really the attention given to it to make it happen. But I want to tell you a little bit about what web components are, what the flaws are when you try to integrate them and make them cross-compatible, and hopefully convince you that it's not such a tall order anymore. And that in fact, we are sitting today in the cusp of the big change, because React 19 is not out yet. And it was supposed to be out this summer, it's not. But React 18 still has problems. So in order to import web components and use them as React components, and then also use the same ones in an Angular application, you need to hack a bit. You need to use wrappers, you need to use libraries, because of some technical details that I'll mention. But in React 19, you don't have to. And they will, I think, become a major player in component libraries. Stuff like Material UI, which is a design system, has no reason not to build a web component library and hit the whole market with one version of the same library. So adoption is trending up, and that's why these features have been introduced in React. You can use them and you can test it for yourself in the React experimental release. And the maturity threshold is what I'm kind of talking about here. We have solutions now for SSR, which we didn't before. We have solutions we have some alchemist conceptions about the SEO, factor here, even though there's some questions still out. But we're getting close to like full adoption, and it will be a big deal for design systems. So let's talk about what a web component is really quick. How much time do I have? Okay. All right. So Shadow DOM, encapsulation. How many libraries, how many tools have you used to encapsulate your styles? Like CSS and JS types, CSS modules, just completely different ideas, completely different tools. Functional CSS class libraries. This problem has been with us since the beginning of componentization of web technology, since Angular 1. And it's still here because we didn't have a built-in thing to do this. So super simple, you instantiate it, and then any element that is attached to that DOM tree is not affected. It's invisible to styles outside and to queries outside. So the style encapsulation is pretty hardcore, but the JavaScript one is not. You can get around it. It just prevents you from doing it unconsciously. But yeah, that's shadow DOM, and then we have templates, which are interesting because they have performance implications. There's a mild performance advantage to using web components over something like React components or Angular components, but it's not huge. But especially in when you're mounting a template, that is optimized, and they can optimize it. So it's just a hidden HTML element that we can use. Okay, and I guess I deleted a slide or something. Custom elements is the last piece, which is being able to register a class that extends HTML elements such that you can, if you can use the same interface that HTML elements use and register it to be used as a regular HTML element, of course. And that is how we achieve componentization. That's how we create components, right? Shadow DOM is how we create encapsulations, and templates is how we use a declarative style, right, to define our UI, which you need, right? Angular has it, React has it. That's actually kind of why we have these libraries to begin with, because before you have to use jQuery and do an imperative kind of programmatic step-by-step update of your DOM, which it's just not scalable. But when you have templating, when you have JSX, it's a totally different game, right? So we have templates now in the browser itself. We have encapsulation that's even better than what we have in our JavaScript frameworks, and custom elements, they're easier to import, I guess. All right, so then the native advantage, of course, is that you can optimize for it. Now, here's the big question. Should we use it, especially for whatever project you're doing, should we use it? So the first consideration is React is still good. React is better than what you can, from the point of view of a team, your value throughput, your velocity, and your risk. The established frameworks are battle tested. We have a ton of resources to tap into about how to solve X and Y problem. But they try to solve a lot of stuff, right? Like Angular for sure tries to do a lot of stuff, but React usually gets piled in with Redux or whatever library you're using these days. Web components only does the component part, right? Like the leaf, the last little bit, right? So we have to compare apples to apples. And if you compare apples to apples, web components technically are superior in that they can do things that JavaScript libraries can't. However, it's completely offset in many cases by the fact that there's way better support, way better understanding, and the way that you write these components in JavaScript is more scalable. Like these frameworks exist so that we can write a lot of code and not have our repository look like a bowl of spaghetti. So this is the first cost, right? We have a smaller community. This is one of the cons, right? Less source material, less information sources. That is a problem with using web components. It's a different art. Like, it's a different thing. You don't just write, we'll get to it, but there is a lazy way that you can write your web components in React or in Angular, but it's not the way that usually it should be done, and none of the major web component libraries advocate it, because it has a different kind of paradigm. It's not built based on a render cycle. It does not. It tries to be thin, and you're closer to the DOM. So it's kind of like we're going back a little bit to a more primitive way of coding, closer a little bit to jQuery, while using component classes. So if you have a React project, and you say, oh, I'm going to make my components with web components so that I can use them in the Angular project, you're having increased cognitive load, maintenance cost, etc. Technical immaturity, sure. SSR solutions are new, they're complex, they work, but who knows if you have an error, how to fix it. SEO, we don't really understand the implications. But let's talk about the benefits. It's future-proof, right? Like this is not gonna go obsolete. It's never gonna be your AngularJS application that now you have to migrate into Angular 2. It's not gonna be obsolete. These are written in stone, and they will continue to get better. Performance, it's a mild improvement, but the improvement happens to be on page load. Because in order to update our DOM, in order to affect, do a delta, do a render, an update render, we have to actually go and edit the DOM using the JavaScript DOM API. So we have ultimately the same tool that React and Angular have for updates. But for mounting, we have templates because we're just copying that particular tree and just injecting some variables. So on page load, the initial render, which is the most expensive and the most important, that one is, I mean, it depends what your application looks like, but it's significant. So it's not a huge change, but it's all concentrated where it matters, which is good. Cross-compatibility, that's a benefit. And that's a benefit that, like, this is, I think, the important part. Like, there were a lot of costs, right? There were a lot of cons that were really, really bad. But if this is a benefit, if this is important to you, if you're making a design system, you might want this, right? So in React 18, you still need a wrapper, and you need to do some stuff. And in Angular, it's fully supported. It's been fully supported since the beginning. But you know how it is. It's never as good as it sounds, and you always have little compatibility issues when it comes to complicated things like forms, routing, anything that is kind of, a little bit more complex, even, happens to React sometimes. So it's good to, be prepared to wrap some stuff. But here's the funny one that is actually kind of cool. AngularJS is surprisingly like super compatible. It might be the best, it might have the best support for web components out of everything. Why? Because of the problem that it had too. If you guys ever used AngularJS, it's very close to the DOM. It actually keeps all of the props and the state variables and all that. You can see them in the document properties. Yeah, Cesar knows what I'm talking about. and when you write your template, right, your JSX, your Angular template, you're actually writing HTML. Like, it's not like Angular where it parses it out into, like JSX, which gets parsed out into JavaScript code. In AngularJS, it stays as HTML, which is closer to the HTML template. So for a couple of reasons like this, AngularJS just works amazingly, which is important because that's another use case. Okay, another one, distribution. So it's easy to consume these things. You can just put a script tag in your page and you have the component library imported. Same thing with you don't need to build them. If you're not using TypeScript, if you don't want to use TypeScript and whatever, like, you don't even have to build it. You can just import it as is because the HTML element classes are all there, whatever. So it's easier to build. You don't have, markup transpilation. Okay, when you have a React project, what is the part of the build that will fail? It will say, oh, we don't have the Webpack plugin for SVGs, or like, it's always the assets, like injected assets, that kind of, that are hairy to configure. But you don't have that problem here for the most part because you're actually writing just straight up HTML, so you don't have to transpile it. And smaller bundle theoretically because they're supposed to be thinner. All right, so here are the viable use cases that I was mentioning. So first, the not use case, the anti-example. Imagine you have an application, it's like a hotel app, whatever, and it's, it's kind of actually no more than that. So you're building like Twitter, it's an intense app, it does a lot of stuff, there's events, there's a lot of state happening, you have to open panes, close panes, whatever. You're writing it in React already, you've already picked that, or you're a React developer already. And you're not going to share these components out with anybody else. Like, this is your product. You don't have a suite of products. You're a product shop, right? And you distribute it not as something that people can plug into their stuff, but as, here's Twitter, you come to my website, you get the app, right? That's the worst possible case. You're only adding problems for yourself by going down this route. What we want is to only handle leaf level UI, want to be thin. Okay, so check out AngularJS migrations. because it's so good at supporting, because AngularJS happens to be so compatible, you can actually migrate piece by piece, component by component, and plugging it back in. You don't have to wait until you have feature parity with the other application. You can just rewrite in web components, plug it right back into the AngularJS application, and still use that one for whatever else you have in the modern stack. If you have a React app or a new Angular app, right? You can replace legacy immediately and get value throughput from the beginning, which kind of makes you relax. It's more agile. Yeah. And then UI libraries, design systems. It's easy to, consumption is easy here, right? It's one of the easiest things to consume from, like technically from a consumer perspective, which is great for this. So it's consumable, it's compatible if we do it right. And you have one source of truth for your brand language and for your UX components, and it's performant. I mean, it's not crazy different, but it's better, And yeah, so just last thing to mention here, this is how you kind of want to do web components, right? You want to keep them thin and hopefully stateless or almost stateless, limited functionality, because what it's missing, and it's kind of by design, is the whole render flow, right? You don't have change detection. You don't have any of that, supposedly, unless you use some heavy library. So you want, and another important part is you keep it thin because you need to decouple your business logic. You need to decouple your app logic for two reasons. One is to keep it thin, again, just to hammer on that point. But number two, you don't want your React developers to have to look or debug inside your web component. That is just terrible. What you want is for them to just trust it, to do the minimum possible thing, and to keep all the business logic inside the part of the code that is actually sophisticated enough to handle that complexity. If you wouldn't write Twitter in jQuery anymore, right? Like you would want to use something that actually helps you. You have context, you have effects, you have state management, right? Yeah, so you want to keep it design-centric, generic if possible, and stable, yeah, of course. All right, are we out of time? I think so, actually. So any questions? I don't think I made it, but I mean, you can read here with Angular elements and Preact are the way that we can emulate what we're used to in web components. Don't do that. It's just a bad idea. From our experience, it just never turns out well because, and all of the internet agrees. You can write a web component in Angular. So instead of writing kind of jQuery style where you go in and actually affect the DOM, you can, run an Angular app in there. But then every instance, carries its own whole bundle. Your bundle is much bigger than it has to be, and you're running an instance of the Ivy renderer for each, because they don't share any of this stuff. They try to be absolutely self-contained, right? There's a better option, which is Preact, which is like a thin version of React. Vue also is kind of comparable, but at the end of the day, you're kind of solving a problem that you shouldn't have. You shouldn't have that much complexity to deal with inside that component. If you're doing your application functionality in there, you're not looking in the right place. Then you have customizable libraries like Fast by Microsoft. So they just have a component library, but you can extend it, and design systems. Use a monorepo. I don't have time to go into it. Yeah, this is kind of how you. Yeah, okay. So the monorepo allows you to have multiple packages. One for the web components library itself that exports web components, and there you can have your own tooling, your own. You do want TypeScript. You do want to distribute it in different ways in ES module or whatever. So you want it in its own package, and then you import that into. You should have two other packages, one for React and one for Angular. Even if you're using React 19, even if Angular supports it. Why? Because once in a while you will hit a compatibility problem. Once in a while you want to be able to go in and be like, okay, this component is complex enough, or it's giving us enough trouble that we can just put it in the platform-specific library. And also, you can take contributions from other teams, because the most important thing that I wanted to get to is adoption for design systems, right? We need to get them involved, get them to see kind of how it works. If they can contribute the code that they already know, that's great. Yeah, handle accessibility if you can in design, and earn their trust through robustness and beautiful documentation. You will not regret the time you spend tweaking CSS on your doc files. Yeah, that's all I got. Any questions?